Number 47 and 6.1, they're asking us to find the area of the region that is bounded by these three equations right here. I'm tempted to say functions, and yeah, I think they all pretty much are, but let's take a look at a quick graph of what it is that we are dealing with here, guys. We have got, of course, the exponential growth curve here of y equals e to the x, which is a graph we should certainly know pretty well, and it looks something like that. Then we have y equals e to the negative x, the exact same function, except the x has been replaced by a negative x. So what that does now is it gives us something symmetrical, and I never draw this one quite as well, over the y-axis, looking something like that. Now what I'm hoping everybody can tell me here is that that ordered pair, where both e to the x and e to the negative x cross the x-axis, is the ordered pair, the y-axis is the ordered pair 0, 1. And that's important because the third thing we need to graph is the horizontal line y equals 2, which that means then it's going to be above that region. So that's what we're looking at right there, guys. Okay, this region here that is a straight line on top and then two curves here on the bottom. Okay, what's interesting about this problem here, guys, is I think we could do it in two different ways, and I'm sure both of them are going to get us the right answer. But the question you guys always want to ask yourself is this region vertically simple, horizontally simple, or both, or neither? Now, this one is definitely not vertically simple. Here's why. If I went to draw a vertical rectangle right here, it's bordered by y equals 2 on top and y equals e to the negative x on the bottom. But if I go to draw a different vertical rectangle, it's got the same top border, but now it has a different bottom border. So I could do this problem vertically with respect to x, but it would require two different integrals here, each one with a different bottom function. Okay, so a lot of times when a region is not vertically simple, that means that it is horizontally simple. So let's think about that. If I were to draw a couple of rectangles here, and then maybe another one right over here, yeah, I think I can see that both of those rectangles are bordered by e to the x on the right and e to the negative x on the left. So this region here is horizontally simple. And that means that integrating with respect to y would probably be easier than integrating with respect to x, simply because I could do this with one integral rather than two. The downside to that is that I would need to solve both of these equations here for x in terms of y rather than the way they're written right now. I'm going to do that, and then at the end I might come back and show you something very different then. That's another route that I'm sure is going to get us the right answer as well. Okay, if we wanted to get x by itself here, how do we undo an e? Natural log. So we end up with y is equal to the natural log, x is equal to, natural log of y, and that's that equation here. Now again, that was y equals e to the x, this function right here, so that's the right border of these two, of this region here. And then for this one, all right, again, if we took the natural log of both sides here, we would get negative x is equal to the natural log of y, so x would equal the opposite of the natural log of y. That would be the second function here, and that one would actually be this border over here on the left. Okay, so what would happen in that case then, everybody? We would say that the area of our region is going to be an integral, and we said taken with respect to y. That tells me that we're setting this thing up horizontally, and we need the right boundary minus the left boundary. Well, the right boundary is right here, the natural log of y, minus the left boundary, negative natural log of y. So minus the opposite is going to make that a plus natural log of y. Limits of integration, lowest and highest values of y in this region. It starts right here at a y value of 1, and it ends right here at a y value of 2. Gotcha. So that's where we're at right there, guys. I suppose it might make life a little easier if we combined the natural log of y plus natural log of y and made that a 2 natural log of y. I'd pull the 2 out in front then and go natural log of y dy from 1 to 2 for the integral there. And integrating natural log of y or x is not something we do very often by hand, so we're going to go to the calculator here, guys, and type in, all right, we're going to put a 2 out in front, and then this handy integral button I just found, from 1 up to 2, and the actual integrand was going to be the natural log of y. Okay, doing all of that with respect to y. That's not good. With respect to y. There we go. That's what I was looking for. And we came up with this answer here, 0.773 if I were to round that, as I usually like to do. So 0.773, and that would be square units for that region there. As I'm looking at this thing geometrically, everybody, this whole region has a height of 1, and that must mean that the region is not quite as wide as I think it is, but I think that answer probably makes some sense. Now, a different way I'm going to check that rather than just using geometry, I said there might have been a different way to do this, and I meant it. What we probably could have done is taken advantage of the fact that this region, you know what, I'm going to switch to green here, that this region here, guys, was symmetric with respect to the y-axis. Meaning that if I had just found the area of this green region right here and doubled it, I think that would have given me the answer as well. So let me try looking at it that way. And in that case, guys, that green region that I have right there is vertically simple, which means I could have done this with respect to x. So this area would be 2 times a definite integral taken with respect to x of, in this case, we would go top curve minus bottom curve. It's stopped on the top by y equals 2, and on the bottom by y equals e to the x. And the limits of integration, the lowest and highest values of x now, this goes from an x-coordinate of 0 until an x-coordinate of, okay, this might get messy here, I didn't think about this. That point is the point of intersection between this curve and this curve. So let's set them equal to each other. E to the x equals 2, not an irrational number, but back to what we were doing here, we get rid of an e by doing a natural log, and x is equal to the natural log of 2. So that would be the upper limit of integration here, natural log of 2. So let's type that in, and I'm hoping we should get the exact same answer that we got right here. So we wanted, let's see if I got this right, 2 times a definite integral that went from 0 up to, here we go, the natural log of 2. Got it. And the integrand right here, again, we did top minus bottom, was y equals 2 minus y equals e to the x power. And doing all that with respect to x, I think should get us the exact same answer we see on the previous line, and sure enough it is. So 0.773, again, getting the same answer twice doesn't guarantee that you've got it right, but if you did it in 2 different ways and you got the same answer right there, we're probably in pretty good shape. Okay, so confidence is high. We got this right answer here for number 47, doing that problem 2 different ways.